Yeah, so good morning, students. Good morning. So we have been learning about elements. We learned about electropositive, electronegative. Do you all remember? Yes, screen is not yet shared. I have to share the screen. I'm just waiting for Nalla Neram. As soon as Nalla Neram starts, we will start. Okay, so in the last class, I was talking to you about my screen is shared now. All of you, you're able to see the screen. This is where I'll be writing. So I hope this is also visible. Okay, okay, good. So let us start. So the thing that we were talking about in the last class is we were talking about electropositive PIVE and electronegative. Are you able to understand these two? Do you remember these two? We said all those elements which have less than 4 electrons in the outermost shell will be electropositive. And then we said all those elements which have more than four electrons in the outermost shell will mostly be electronegative. So we gave example: lithium, beryllium, magnesium, sodium, calcium, potassium, then again zinc, aluminium, iron. So we said all these are having 1 or 2 or 3 electrons in outermost shell. So these are electropositive, and we call them something called as metals. And then we had carbon, we had oxygen, we had nitrogen, we had sulfur, we had phosphorus, we had chlorine, we had bromine, we had fluorine. All these we call them as electronegative elements. And we said electropositive elements want to give electrons. Now electronegative elements can take electrons or share. Okay, they can take electrons or share. Now in such a situation, these elements will only react with these elements, but these elements may react within themselves. These elements may react within themselves, but these elements will always have to react with this, because they only give. Only these guys can take. Okay, do we understand this? Why do some give and take? We said some give and take to make sure that they have an octet or noble gas configuration. So we will make a note of this. Every element wants or tries to have nearest noble gas configuration. Okay, This it does by A, giving electrons, B, by taking electrons, and C, by sharing electrons. Okay, so we will make a note of this, and this is the fundamental reason why elements react. So if somebody asks you, okay, why do elements react? Elements react because they want to have nearest noble gas configuration. So in the process of attaining nearest noble gas configuration, they either give or they take or they share, and these processes lead to the formation of a compound. Yeah, these lead to the formation or formation of a compound. Okay, when materials transform, when materials undergo transformation, there are two types of transformation. There are two types of transformation. One is a physical transformation. A second one is a chemical transformation. You have a physical transformation and you have a chemical transformation. Materials undergo two types of transformation: physical transformation and chemical transformation. A chemical transformation is also called as a chemical reaction. Chemical transformation is also referred to as a chemical reaction. So we will look at chemical reactions. Okay, I will improve my handwriting. First slide. I told you last time electropositive and I told you electronegative. Electropositive, electronegative. Then I told you these are the electropositive elements. Electropositive elements are also referred to as metals. Then these are some of the electronegative elements. Electronegative elements are also referred to as non-metals. So you have metals and you have non-metals. Then I am saying that every element wants or tries to have nearest noble gas configuration. This it does by giving electrons, taking electrons, or sharing electrons. Okay, and this explains why elements react. This explains why elements react. Then when we talk of formation of a compound, then when materials undergo transformation, there are two types of transformation. One is physical transformation. Physical transformation means solid can change to liquid, can change to gas. So this is an example of a physical transformation. Then there is an example of a chemical transformation. A chemical transformation, we can also refer it to as a chemical reaction. So now I'm going to talk more about chemical transformations. So chemical transformations means certain materials transform into another type of material, and that is accompanied by a chemical reaction. Okay, so as of now, Divya Priya, I hope you are able to understand. Kabil, I won't be able to repeat from the beginning. I'm sorry. If five people come and all of them ask me to repeat, it won't be possible. Okay, I will send you the recording. You please go through it. There is no problem. Okay, so I hope you are able to understand this. So now I'm going to start with chemical reactions. So we will first start with the types of chemical reactions. Okay, types of chemical reactions. So the first type of chemical reaction that we will talk of is a chemical combination. Combination, also referred to as a simple combination. Okay, in a simple combination reaction, two elements combine. Two elements combine to form product. Two elements combine to form product. Say for example, H2 plus O2 forms H2O. Always a chemical reaction is to be balanced. Sodium plus hydrogen will form sodium hydride. So this is a chemical reaction. Carbon plus sulfur will form carbon disulfide. This is carbon disulfide. Hydrogen combines with chlorine to form HCl, hydrogen chloride. H2 plus O2 will form water. Sodium plus H2 will give NaH. Carbon plus sulfur will give you CS2. H2 plus Cl2 gives you 2HCl. So these are all simple combination reactions. Okay, so first thing is, are you able to hear me clearly or no? Are people having difficulty listening, hearing what I am saying? You can't understand. What you can't understand? Are you able to hear? If it is yes, sir, means you are able to hear me clearly. Okay, we can hear you. Are you able to see the screen? I am going very slow only. Okay, so for some people it is breaking. Now your internet is very poor, pa. If my internet is bad, now everybody will not be able to hear. Okay, see, I am talking about chemical transformation. I have finished structure of an atom, CHEMICAL, chemical transformation. So we are having the next chapter as transformation of substances. In transformation of substances, I am taking the one part of it, that is chemical transformation. So in chemical transformation, we talk about chemical reactions. A chemical transformation happens when there is a chemical reaction. So I am talking about a chemical reaction. Okay, now I am talking about the first type of chemical reaction, which is called a combination reaction. Combination, combination. Here, combination reaction. In a combination reaction, two elements combine to form a compound. In a combination reaction, two elements combine to form a compound. And I wrote four examples. And I wrote four examples for combination reactions. Okay, is this clear? Yes, my friend Rishiraj, Vishal, Govind. Yes, Govind, what about you? Kapil. Yes, okay. So if it is clear, then I will explain. I want to now explain these reactions. So I want to explain H2 plus O2 gives you H2O. Now I want to discuss this. I am seeing that this is a non-metal. Hydrogen is a non-metal. Oxygen is also a non-metal. Okay, so two non-metals are combining. When two non-metals combine, they give you something. They give you something, and that product is formed by sharing of electrons. Sharing of electrons. When non-metals combine, they do so purely by sharing. Non-metals can combine only by sharing. Okay, so if you look at oxygen, this is the nucleus of oxygen. Oxygen has 2 electrons in its first shell. Oxygen has 6 electrons in its second shell. Okay, 1, 2, 3, 4, 5, 6. Then hydrogen. Hydrogen has 1 electron. So this is hydrogen, has 1 electron in its outermost shell. So these two come together, they share. Then another hydrogen also comes. Another hydrogen also comes. This also has 1 electron. Now these two, they will share. So now hydrogen has 2. This hydrogen has 2. If you look at oxygen, it will have 1, 2, 3, 4, 5, 6, 7, 8. So now oxygen also has 8. Hydrogen has nearest noble gas configuration. So they both are happy. So they both are happy. So such a compound which is formed by sharing of electrons is called covalent compound. Covalent compound. Such a compound formed by the sharing of electrons is referred to as a covalent compound. So you have two types of compounds: covalent compounds, which are formed by sharing of electrons, and electrovalent compounds, which are formed by the transfer of electrons. So this is an example of a compound formed by the sharing of electrons. Am I clear? Yes, so these are but how do you combine these? Okay. So the way it will happen is this. Now there will be an overlap. This is oxygen. This is the first shell of oxygen. This is the second shell of oxygen. And then this is hydrogen. This is the first shell of hydrogen. So now there is this is okay. Now this is another shell of hydrogen. Now this is the nucleus. Hydrogen is here. So here. Now 1, 2, 3. 2 should be there up and 2 will be there here. So now you see oxygen is having 1, 2, 3, 4, 5, 6, 7, 8. Hydrogen is also having 2. This hydrogen is also having 2. So now they are all having nearest noble gas configuration. So this is the way you can demonstrate. The other way you can demonstrate is oxygen. Oxygen has 6 electrons in outermost shell. So here it will come with hydrogen, here it will come with hydrogen. So this is going to be the structure for water. So now you see hydrogen is having these, this hydrogen is having these, and these are the outermost electrons of oxygen. So you get H2O. Okay, now this is what is known as the Louis dot structure. So we have shown the Louis dot structure for water. Okay, we have shown the Louis dot structure for water. Okay, is it clear? Okay, so these bonds are formed by the overlapping of outermost shells. These are called the covalent bonds. Covalent bonds are formed by the overlapping. So if my handwriting is bad, I'm dictating. Covalent bonds are formed by the overlapping, overlapping overlapping of outermost shell. Okay, so that is how the covalent bonds are formed. So these are called covalent compounds. Okay, so water is a covalent compound. Another example I can give is ammonia. Nitrogen plus hydrogen will form ammonia. This is AMMONIA, ammonia. Okay, so this is a simple combination reaction. One element combines with another element to form ammonia. Okay, now ammonia, you have nitrogen. Nitrogen, what is the atomic number for a nitrogen? 7. So in the first shell you have 2, second shell you have 5. So what happens? Nitrogen needs 3 electrons to complete octet. So 3 electrons means nitrogen will need 3 electrons. So one hydrogen will come from one side, one hydrogen will come from another side, another hydrogen will come from another side. Thus it will form water. It will form ammonia. Okay, please work this out, draw this diagram, then I'll repeat. Hello? Yeah. Yes, good morning. Yes, sir. Yeah. You can attend the test only once. You send me your account details. Message me. WhatsApp. Yes. Yeah. Okay. It will not work out like that. Yeah, it will not work out like that. You have to show. Okay, you send me message. I will see. Yeah, please send me message and then I can do something. Just by talking, I can't do anything. Yeah, please. Yeah. Oh, okay. So here what will happen is one hydrogen will come, one hydrogen will come, one hydrogen will come. So nitrogen, this is nitrogen, first shell, then again second shell of nitrogen, then there will be hydrogen will overlap here, one hydrogen will overlap here, another hydrogen will overlap here, then 2 electrons will remain here. So now this is how ammonia is formed. So this is hydrogen, this is hydrogen, this is the nucleus of hydrogen, nucleus of hydrogen. Now hydrogen has 2, nitrogen has 8. So both are having stable configuration. So this is also formed by the sharing of electrons. Compounds formed by the sharing of electrons are called covalent compounds. Nitrogen is a non-metal. Hydrogen is also a non-metal. So one non-metal reacts with another non-metal. So non-metals combine together to form ammonia. Sorry, non-metals form together to form covalent compounds. Okay, so I hope this is clear. So next week onwards, I will start keeping tests. Coming week, periodic properties, I will keep test. Okay, next. Next, you have electrovalent compounds. Electrovalent compounds. Electrovalent compounds are formed by transfer of electrons. They are formed by the transfer of electrons. So what do we mean by transfer? Now let us look at a compound. Let us look at sodium. Sodium has 11 electrons. Na has 11 electrons. So what will its structure be? 2, 8 and 1. So in the first shell it will have 2. In the second shell it will have 8. 1, 2, 3, 4, 5, 6, 7, 8. And in the third shell, it will have only 1. Then let me look at chlorine. Chlorine has 17. So it will have 2, it will have 8, and then it will have 7. So in the first shell, you have chlorine. Then here you have 2 electrons. Then here you have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8 electrons. Then you have one more. Here you have 1, 2, 3, 4, 5, 6, 7 electrons. Now, chlorine needs 1 electron to get noble gas configuration. So, sodium will give this electron and it will come here. Sodium will give this electron and it will come here. Once one electron goes, sodium will become positive. Why? Because electrons are negative. Electrons are negative. So if one electron goes away, sodium will become positive, and chlorine got 1 electron excess, so it will become negative. Yeah. So positive, negative, they attract each other. So they come closer and it will become NaCl. NaCl is nothing but the common salt. The common salt that we are eating is NaCl. Okay, and such compounds are called electrovalent compounds. You have covalent compounds and you have electrovalent compounds. This is also a combination reaction. Yeah, you have to learn it. It may be neutral, it may be acidic. We are not talking about acidic basic. We are only saying what kind of compounds are formed, when will they react and how will they react. So this is a metal, this is a Na is a metal, this is a non-metal. So metal reacts with a non-metal by transfer of electrons. So these are called electrovalent compounds. Non-metals react with each other to form compounds. They are covalent compounds. Okay. So when you look at combination, metal Metal can combine with non-metal. Non-metal can also combine with a non-metal. Okay, a metal can combine with a non-metal, and non-metal can also combine with a non-metal. This is a electrovalent compound. This is a covalent compound. Yeah, so you have an electrovalent compound and you have covalent compound. Okay, and we were talking about combination reactions. In a combination reaction, one element combines with another element. One element combines with another element to form a compound. More examples. Na plus Cl2 gives you 2NaCl. This is an electrovalent compound. Then more I can give. H2 plus Cl2 forms 2HCl. Okay, then carbon plus oxygen will form carbon dioxide. So these are all examples of combination reaction. Combination reaction. Why do elements react? Elements react so that they can have a complete octet. Elements react so that they have a complete octet. Okay. Okay, yes. That we will come to. Later on, we will come to that. Okay, yes. We have to draw those diagrams and understand. In the exam, I can ask. Shakti, Sri Shakti. Hope you are able to understand. Okay. So, if you are getting it, then let me move ahead. So combination is over. Okay. Now a special type of combination, I shouldn't say a type of combination. So let me just remove it. Let me just say that if a substance reacts with oxygen, we call it a combustion reaction. Combustion is combination with oxygen. Okay, combustion is combination with oxygen, reaction with oxygen. So if you have magnesium, magnesium will react with oxygen to form 2MgO. Calcium will react with oxygen to form calcium oxide, so 2CaO. H2 will react with oxygen to form 2H2O. So these are all combustion reactions. Okay, so these are all elements which are combining, not only elements, other things. This is a gas, methane. Methane will react with oxygen to form CO2 plus H2O. So these are all combustion reactions. What is combustion? Combustion is nothing